Hey guys, welcome back to episode 2 of our SNEC 2026 Buyer Guide series. If you watched episode 1, you already have a basic brand screening framework. Today, we're diving deeper into the core equipment that dictates your project's 25-year ROI and grid compliance pass rate, inverters, and energy storage systems. Before we jump into brand breakdowns and parameter standards, let's clarify one critical question: why your old purchasing logic no longer works in 2026. This is essential context every global B2B buyer needs before placing any orders. First, let's talk about market cost trends. After 2 years of sharp declines, global energy storage cell prices bottomed out and rebounded noticeably in 2026. Driven by rising lithium and raw material costs, mainstream 314A LFFE cell prices have climbed to 5 to 6 cents per watt-hour, up more than 15% year-over-year. The era of ultra-cheap inventory is over. Blind low-cost procurement now translates directly to hidden long-term asset losses. Second, policy and grid code thresholds have been fully upgraded. The EU is tightening PCS grid access rules and revising the II Industrial Acceleration Act, pushing grid-tied equipment toward localized manufacturing or technology transfer. The US has updated fee-related subsidy rules requiring energy storage projects to meet a 55% unrestricted supply chain ratio to qualify for the 30% ITC tax credit. With standards rising annually, equipment that passed inspections in 2024 and 2025 will fail 2026 Western grid compliance audits outright. Third, the industry has hit a major technology inflection point. 2026 marks the year string energy storage fully replaces centralized storage. Combined with the widespread adoption of high-power bifacial modules, traditional inverter matching schemes can no longer keep up with modern power generation efficiency standards. Picking the wrong equipment will not only lower your power output, but also drag down your PV asset residual value through 2030. I hear the same confusion from buyers every single week. Many teams invest in premium brand inverters, yet their projects still trip offline randomly. Many developers deploy costly storage systems that simply cannot align with local grid regulations. From an insider engineering and buyer perspective, this is rarely a quality issue, it's a mismatch issue. Flagship models are overkill for small budget projects, while simplified entry-level units cannot handle strict Western compliance standards. Old-school buying experience no longer applies to 2.0 to 6E's rapid hardware iterations. Today, I'm sharing 100% field-tested standards, hardcore engineering parameters, real-world budget controls, risk avoidance logic, financial cost analysis, and optimized supply chain strategies. Let's dive in. 2. Top brand core strength and exact buyer scenarios. In this section, I'll break down each brand's true field strengths, exact applicable scenarios, and most importantly, which projects should avoid them entirely. All insights come from verified on-site engineering data, not official marketing material. To help you screen faster, I've categorized all 2026 mainstream brands into 3 clear tiers. 1. National Strategic Grade, GCL, BEA, SPIC. Ideal for large-scale base projects and government benchmark programs. 2. Global Top-Tier Grade, Huawei, SINENG, Sungrow, CATL. Full Scenario, Finance-Compliant Asset-Grade brands. 3. Scenario Specialist Grade, Qilin, GoodWe, DEYE, SOLAX. Cost-effective options for segmented, distributed, and weak grid markets. GCL 2026 SNEC Scenario-Based New Products and Innovative Process. GCL unveiled its full scenario customized EcoPower Mate mobile PV storage integrated solution, alongside 5 tailored module and inverter matching systems at SNEC 2026. It's the first industry solution to deliver scenario-based equipment iteration for diverse regional and environmental conditions, filling a critical gap in refined environment-specific PV storage matching. Field-verified core technologies and craftsmanship include 2 key upgrades. First, exclusive scenario customized engineering with dedicated dust-proof, anti-glare, desert high voltage, marine anti-corrosion, and commercial lightweight series, built specifically for harsh operating environments. Second, newly optimized mobile PV storage integration technology that fully combines PV modules, inverters, and storage units for plug-and-play, rapid mobile deployment, perfectly supporting temporary job sites and off-grid remote areas. Third, upgraded BC and TOPCon dual process integration boosts module power generation efficiency while pairing seamlessly with GKL's self-developed high adaptability inverters for improved overall system efficiency. Fourth, marine-grade composite framing and desert-specific steel reinforcement processes drastically enhance wind resistance, corrosion resistance, and aging tolerance, ensuring reliable operation in coastal salt spray and desert wind sand environments. Key new product highlights include the flexible capacity EcoPower Mate mobile storage system, built for outdoor construction, remote pastoral zones, and emergency power backup. The 2000 volts desert-optimized PV storage system cuts overall construction costs by 8% and line losses by 10%, making it the ideal solution for large desert-based developments. The anti-glare customized variant meets strict low interference standards for airport and highway auxiliary PV projects. Best use cases: large-scale desert PV bases, offshore and coastal corrosive environment projects, airport and highway auxiliary PV storage systems, and temporary mobile energy supply deployments. Buyer takeaway: GKL's core strength lies in highly customized scenario solutions. It delivers average cost performance for standard conventional projects, but offers unmatched technical advantages for special environment and application-specific developments. BEA 2026 SNEC Industrial Grade New Technology Upgrade. As a global benchmark for industrial-grade power equipment, BEA launched its next-gen high-power industrial inverter plus 2000 volts high-voltage energy storage system at SNEC 2026. The upgraded lineup prioritizes high voltage, high power output, extreme stability, and grid compatibility, targeting exclusively large industrial, governmental, and high-value financed key projects. Field-verified technical upgrades start with a breakthrough 2000 volts high-voltage grid-connected architecture, surpassing the traditional 1500 volts industry limit to reduce line losses by 12% and elevate overall system power output efficiency. BEA also integrates full industrial-grade anti-corrosion craftsmanship, featuring C5M maximum level salt spray resistance and desert dust-proof customization to withstand extreme outdoor and industrial operating conditions. Third, newly upgraded grid adaptive active harmonic suppression enables real-time dynamic filtering, maintaining the 1, 2, and exceeding top Western grid standards. Fourth, redundant power architecture and multi-level self-recovery technology deliver 99.99% system uptime, satisfying the ultra-high stability demands of national key infrastructure and financed asset projects. The new 350 kilowatts plus high-power industrial inverter supports large-scale parallel grid connection with robust overload tolerance and consistent derating-free operation under high-temperature, high-load conditions. Its matching high-voltage liquid-cooled energy storage cabinet features highly integrated design, minimal footprint, and streamlined centralized O&M. Purpose-built for utility-scale ground power plants and industrial park storage deployments. Best use cases: government bidding mega projects, industrial parks centralized PV storage integration, ultra-large ground power stations, high-value financed asset projects, and high-voltage grid upgrade supporting initiatives. Buyer takeaway: BEA's industrial-grade hardware carries premium stability and safety thresholds with higher upfront investment. It is not cost-effective for small to medium civilian distributed projects, remaining the go-to solution for high-standard industrial and official infrastructure developments. Huawei. Field-verified performance specs include a 98.9% maximum efficiency rate and 99.9% EMP tracking accuracy. Huawei's AI-driven grid adaptive algorithm delivers superior high-temperature and salt spray resistance, backed by full UL, VD, and IEC global certification coverage. Best use cases: large-scale EPC projects, US and EU high-standard grid-tied developments, and compliance-focused zero-risk asset holdings. Buyer takeaway: Huawei equipment commands a legitimate market premium, It is not designed for ultra-low budget residential builds. Buyers pay not just for hardware quality, but for guaranteed compliance eligibility, bank-friendly financing terms, and long-term grid stability. It remains the safest option for formal bidding and multi-decade asset holding projects. SINENG 2026 SNEC New Tech and Full Scenario Upgrade. As a global leader in PCS technology and large-scale grid-forming solutions, SINENG launched a fully updated lineup of commercial and utility-grade hardware at SNEC 2026. The upgrade centers on true grid-forming architecture, ultra-high power density optimization, and full-scenario liquid or hybrid cooling iteration, bridging key technical gaps in high-stability grid connection and large-capacity energy storage deployment. Core technical upgrades start with second-generation enhanced VSG grid-forming technology, which breaks traditional grid-following limitations to enable stable off-grid standalone operation and weak grid self-adaptation. Its 180 ms ultra-fast primary frequency response effectively mitigates grid oscillation and voltage fluctuation on high renewable penetration networks. New ultra-high power density integration allows the upgraded 465Q510Q string inverters to support 1,650 volts ultra-high DC input, compatible with 5 megawatts plus large-scale PV arrays, and drastically cutting DC cabling costs and system line losses. The updated SEN 75 1-5 HD commercial hybrid inverter achieves 98.8% peak conversion efficiency via high-precision power electronic tuning, supporting 10 ms seamless on-off grid switching, 150% short-term overload capacity, and 200 ms rapid peak power output perfectly tailored for commercial peak shaving and emergency backup scenarios. Full-link safety upgrades include AFSI 2.0 intelligent arc fault detection, dual-stage DC lightning protection, and multi-layer electrical and thermal safeguards, eliminating operational hazards in outdoor industrial environments. Standout new products include the 125Q488 kWh commercial liquid-cooled energy storage all-in-one system, which integrates PCS, BMS, and intelligent thermal management, with full IP67 protection and minimal low-temperature attenuation. It reduces long-term field failure rates by 70%. The 1,725 kilowatt centralized PCS solution supports single-site expansion up to 13.8 megawatts, cutting overall EPC comprehensive costs by 38% versus conventional setups, and setting a new cost efficiency benchmark for utility-scale storage stations. Best use cases: utility-scale PV base stations, commercial and industrial peak valley arbitrage storage, weak grid high renewable penetration projects, and large-scale grid frequency or voltage regulation support systems. Buyer takeaway: SINENG's competitive edge lies in industrial-grade grid-forming stability and large system cost optimization. It outperforms most mainstream brands on centralized utility projects and grid auxiliary service applications, though it holds no distinct price advantage for small residential distributed builds and is not recommended for ultra-low budget micro projects. SPIC 2026 Seconds NEC Original Innovative Technology and Scenario Exclusive Solution. As a national-level new energy technology pioneer, SPIC premiered its in-house developed Chuno ultra-high temperature Carnet energy storage system, Galaxy full submerged liquid-cooled ESS and synchronous grid-tie inverter platform at SNEC 2026. The suite delivers disruptive innovation for long-duration energy storage and large-scale grid stability regulation. Field-verified core technologies include the world's first 560 ultra-high-temperature heat pump Carnet battery system, breaking conventional storage temperature limitations. It features flexible site deployment, zero geographic restrictions, and extended cycle lifespans, solving the short duration and location-dependent pain points of standard electrochemical storage. The upgraded supermolecular full submerged liquid cooling architecture creates uniform cabin temperature distribution, limiting battery temperature deviation to within 2, and drastically slowing capacity degradation. SPIC's proprietary PV storage synchronous generator topology combines DC coupling and AC grid forming architecture to mimic traditional synchronous generator operational characteristics. It delivers 5 ms ultra-fast voltage regulation and 188 ms primary frequency response, supporting GW-level cluster expansion to meet ultra-large ground power station grid-tie demands. The integrated PCS step-up cabinet consolidates inverters, transformers, and distribution hardware, simplifying on-site wiring, reducing footprint by 30%, and boosting overall system integration efficiency. The Galaxy Submerged Liquid-Cooled Commercial Storage All-in-One has completed overseas commercial validation in Mexico, proving reliable 25-year operation in high-temperature, high-humidity, harsh environments. The new Carnet long-duration storage platform targets grid-scale peak shaving and capacity reserve applications, resolving the long-duration bottleneck for large new energy bases. Its matching high-power grid-tie inverter suite is custom-engineered for national strategic energy projects with top-tier industrial stability standards. Best use cases: national large-scale new energy-based developments, grid-level long-duration energy storage peak regulation, overseas high-temperature and high-humidity commercial storage projects, and governmental key energy demonstration programs. Buyer takeaway: SPIC hardware targets strategic, large-scale benchmark projects with industry-leading safety and long-term stability. Its high project threshold and strict matching requirements make it unsuitable for small to medium conventional distributed builds. It is the preferred choice for investors prioritizing multi-decade asset appreciation and policy risk mitigation. SunGrow. Field-verified specs include 350 kilowatts high-power model configurations with 12 independent EMP channels. SunGrow's mature liquid-cooled storage architecture delivers ultra-low long-term failure rates, superior heat dissipation performance, and consistent continuous operational stability. Best use cases: utility-scale power stations, large batch EPC orders, long-cycle asset projects, and centralized grid-tied systems. Buyer takeaway: SunGrow offers industry-leading cost performance for large centralized projects. Its consistent build quality eliminates excessive after-sales maintenance and downtime losses. Among all top-tier brands, its liquid-cooled storage lineup maintains the lowest long-term comprehensive O&M costs. CATL 2026 Seconds NEC New Tech and Product Upgrade. 2026 marks a major technical upgrade year for CATL Energy Storage. Unveiled at SNEC 2026, the updated 3R generation Qilin battery and sodium-ion storage system rewrites performance standards for extreme condition energy storage. With fully optimized core craftsmanship, structural design, and intelligent management systems. Key field-verified upgrades start with a mature 3R Gen Key TP cell-to-pack integrated process, boosting pack volume utilization from 55% to 72%. The ELF-FE system reaches watt-hours per kilogram energy density, while ternary systems hit 265 watt-hours per kilogram, delivering high-density integration without compromising safety. Industry-exclusive nano-rivet structural reinforcement, low lithium consumption anodes, passivated cathodes, and bionic self-repairing electrolyte extend cycle life to 5,500 plus full cycles with tightly controlled capacity degradation. Full temperature adaptive technology enables stable operation from 40 ultra-low cold to 60 extreme heat. Custom low viscosity cold resistant electrolyte and self-temperature regulating cell structures eliminate power derating in desert and high latitude freezing environments. Full wireless BMS coverage and 4-dimensional aerospace-grade safety protection deliver real-time cell monitoring, fault pre-warning, and active thermal management, mitigating long-term thermal runaway risks. Standout new products include the next-gen long-duration sodium-ion storage system, which breaks traditional ELF-FE cost barriers with superior low-temperature performance and extended cycle life. Ideal for low-budget, long-cycle storage projects in high-latitude cold regions. The revised liquid-cooled storage cabinet adopts modular integrated design, cutting on-site installation time by 40% and significantly reducing long-term O&M overhead. Best use cases: Middle Eastern high-temperature desert zones, European high-latitude cold regions, long-duration grid storage, large-scale ground power station auxiliary storage, and overseas extreme environment long-term asset holdings. Buyer takeaway: CATL's upgraded processes and premium materials raise upfront costs, but eliminate massive long-term equipment replacement failures and capacity attenuation issues in harsh environments. For 10-plus year-long duration storage assets, its comprehensive LCOE outperforms generic battery solutions, justifying the upfront premium. Qilin field-verified performance includes the 1.5 ultra-clean power quality, fully compliant with strict EU harmonic standards, plus 180 volts low-voltage startup capability for enhanced grid adaptability. Best use cases: European commercial distributed projects, mid-size formal grid-tied systems, and medium-scale rooftop builds pursuing balanced cost and full compliance. Buyer takeaway: Qilin delivers the most balanced performance for mid-tier commercial projects, with controllable quality and pricing. It offers complete Western certification coverage with zero compliance risk, and carries a lower market premium than Huawei and Sungrow. GoodWe field-verified strengths include 10 ms seamless on-off grid switching, flexible modular architecture, and superior weak grid adaptation with strong low-voltage fault tolerance. Best use cases: Southeast Asian, African, and Latin American off-grid, and weak grid projects with unstable local voltage conditions. Buyer takeaway: GoodWe is not built for strict US or EU grid compliance projects. Its core advantage lies in extreme weak scenario adaptation, rather than high-standard grid certification, and it cannot pass premium Western grid inspection protocols. DEYE 2026 Seconds NEC New Tech and Product Full Upgrade. As a global leader in residential and small C&I inverters, DEYE unveiled its 6th-generation hybrid ESS inverter series and updated ADQ1-5QC and IPCS platform at SNEC 2026. Full upgrades to semiconductor hardware, structural craftsmanship, and intelligent energy management resolve the bulkiness, low efficiency, and weak grid adaptability issues present in older generations. Core field-verified upgrades start with full adoption of SIC silicon carbide semiconductor technology, which optimizes power conversion circuitry, reduces overall equipment size and weight, and boosts power processing efficiency by 2.3%. Updated multi-channel EMT algorithms and low-voltage startup technology deliver ultra-wide voltage adaptation and enhanced anti-interference performance for unstable grids. New modular industrial design enables flexible system scaling. The 125 kW ESS inverter supports up to 10 parallel units for 1.25 MW system builds, while the ADQ1-5Q PCS platform allows 20-unit parallel deployment for maximum 2.5 MW single-site capacity. DEYE's upgraded cloud AI management system integrates proprietary Copilot intelligent strategies for automatic charge-discharge optimization, real-time electricity price arbitrage, and VP virtual power plant linkage. Residential 310Q 6th-gen hybrid models support 50-70 A bypass current to stabilize power supply in complex household electrical environments, with flawless on-off grid switching. The new plug-and-play micro-hybrid ESS features a 2.56 kWh base capacity, with expansion up to 102.4 kWh. Perfect for residential and small commercial emergency backup. All new models hold full TÜV, CE, and N505 for 9 Western certification packages. Best use cases: global residential villa bulk orders, Southeast Asian or African or Latin American weak grid off-grid projects, small to medium C&I distributed storage, and low-budget short-cycle overseas PV storage integrations. Buyer takeaway: DEYE's new lineup retains low MOC and high-cost performance advantages, while fixing legacy low-efficiency pain points. It is the most economical solution for small to medium batch orders, but is not suitable for high-standard Western grid-compliant large-scale bidding projects. SOLAX 2026 Seconds NEC New Tech and Premium Iteration. As a leading global distributed PV storage brand, SOLAX fully upgraded its 3rd generation smart hybrid inverter and liquid-cooled mini ESS system at SNEC 2026. The updated lineup prioritizes high-efficiency power generation, ultra-quiet operation, and intelligent scenario adaptation, targeting mid to high-end residential and commercial overseas markets. Core technical upgrades include a next-gen high-precision EMT algorithm, with 99.8% tracking accuracy, perfectly matching 2026 high-power bifacial modules, with zero generation mismatch loss. Optimized full link loss reduction leverages low-loss magnetic materials and refined circuit layout to boost peak conversion efficiency to 98.7%. Enhanced weak grid adaptation enables 160 volts ultra-low voltage startup and ultra-wide voltage ride-through, stabilizing operation in highly unstable emerging market grid environments. New silent thermal design combines variable frequency intelligent fans and integrated heat sinks to cut operational noise by 15 dB versus older models, complying with strict Western residential noise regulations. The updated commercial liquid-cooled Mini ESS integrates PCS, BMS, and thermal management into a single all-in-one unit with full IP67 waterproof or dustproof protection. It supports 24/7 continuous stable operation with ultra-low long-term failure rates. Residential flagship models deliver one-click on off-grid switching, intelligent peak shaving, and household self-consumption optimization. Best use cases: mid to high-end residential PV storage builds in Europe, Australia, and Southeast Asia. Medium-sized commercial distributed grid-tied projects, and low-noise high-stability scenario deployments. Buyer takeaway: SOLAX's new generation balances full compliance, high efficiency, and reasonable pricing, with complete Western certification coverage. It serves as a premium mid-tier alternative, ideal for projects prioritizing refined user experience and long-term operational stability. 3. System Compatibility and Matching Risk Avoidance 2026 Core Upgrade. Most buyers fixate on individual equipment parameters while overlooking system compatibility, the #1 hidden cause of underperformance and frequent failures in 2026 projects. With high-power bifacial modules and new generation storage systems now standard, these updated matching rules are non-negotiable. First, updated optimal DC or AC ratio standards. Traditional 1.0-1.1 ratios are obsolete for 2026 high-efficiency bifacial hardware. For utility-scale ground stations, the ideal ratio ranges from 1.25-1.3. For commercial distributed builds, 1.2 delivers the best cost-to-performance balance. Overly high ratios create overload clipping losses, while overly low ratios waste inverter power capacity. Second, verified inverter to storage matching logic. Huawei inverters paired with CATL storage cells form the gold standard for large formal overseas projects. With optimized adaptive algorithms, minimal communication mismatch, and superior long-term stability. For mid-size commercial builds, Qilin paired with mainstream ELF-FE cells delivers stronger cost performance. Mixing different core hardware brands on weak grid-off-grid sites is not recommended, as it triggers protocol conflicts and frequent offline trips. Third, mandatory overseas communication protocol standards. US and EU grid-tied projects require SunSpec and IEEE May 2030 protocol support for full compatibility with local grid monitoring and inspection infrastructure. Basic Modbus connectivity only supports minimal operation and cannot pass high-standard grid audits or intelligent supervision checks. Fourth, future-proof upgrade compatibility. When selecting inverters today, reserve native support for sodium-ion battery systems. Legacy low-end inverters cannot adapt to new low-voltage high-capacity sodium-ion storage architectures, risking full system obsolescence within 2 to 3 years and raising asset renewal costs. 4. Financial dimension, LCOE, and hidden cost breakdown. B2B buyer core profit logic. Most small and mid-sized buyers only compare upfront capex pricing, while top-tier EPCs and investment firms prioritize LCOE levelized cost of energy, the true 25-year profitability indicator for new energy assets. First, rationalizing brand premium value. The 10-15 upfront premium for Huawei and Sungrow hardware functions as risk hedging, not pure brand markup. Their ultra-low field failure rates reduce annual downtime losses by 80% compared with generic alternatives, while comprehensive global after-sales infrastructure drastically cuts maintenance labor and time costs. Over a 20-year operational lifespan, higher initial capex is fully offset by minimized LCOE. Second, quantifying hidden failure costs. Generic low-cost brands carry a 3.5 annual field failure rate globally. For a 1 MU scale project, unplanned outages generate tens of thousands of dollars in annual generation losses, plus expensive cross-border logistics and labor repair costs, pushing total long-term expenses far above premium-tier hardware. Third, multi-layer revenue stacking, the core 2026 profit driver. Traditional procurement strategies only focus on cost reduction, while professional investment teams maximize IRR through layered revenue stacking. Every mature regional power market features exclusive profit mechanisms that demand tailored inverter and storage system configuration. European projects capture arbitrage gains across day-ahead DEYE and intraday ID market cycles. US projects combine energy arbitrage with fixed capacity payment subsidies. Australian NEM market assets generate supplementary revenue via FACEAS grid auxiliary frequency regulation services. In 2026, projects without tailored tariff arbitrage strategies will overestimate actual IRR by 2-4. Precision equipment selection and intelligent strategy tuning unlock otherwise hidden project profitability. Fourth, project bankability and financing friendliness. In Western financial markets, hardware from certified top-tier brands including Huawei, Sungrow, and Qilin significantly improves project loan approval odds and reduces interest rates. Financial institutions maintain strict risk preferences for verified premium-grade equipment. Projects utilizing lesser-known hardware face financing restrictions or reduced lending limits, directly compressing profit margins. 5. 4-dimension personalized selection system core methodology. Forget generic best product rankings. Your optimal solution derives from 4 core dimensions: local market regulatory rules, project scale, budget constraints, and in-house O&M capacity. This is the only standardized selection framework for 2026 global PV storage developments. First, your local market standard and policy threshold. Strict compliance and subsidy markets US, EU, Australia prioritize Huawei, Sungrow, and Qilin. Full UL, VD, and IEC certification coverage plus qualified supply chain attributes guarantee grid inspection eligibility, subsidy compliance, and financing approval, while mitigating policy and regulatory risk. High heat desert regions Middle East deploy Huawei high temperature variants paired with CATL storage. Prioritize thermal resilience and dust-proof durability over pure generation efficiency to sustain reliable operation in extreme harsh climates. Weak grid emerging markets Southeast Asia, Africa, Latin America select GoodWe, DEYE, and Enphase. Prioritize low voltage startup tolerance, grid anti-interference performance, and strong off-grid adaptability to cope with unstable local power grids and frequent voltage fluctuations. Second, your project scale. Small residential shops and villas, DEYE, Enphase, simple and stable, low Mach. No redundant performance waste, perfectly matching small scenario needs. Medium commercial rooftops, Qilin, GoodWe, balanced quality and cost, meeting commercial grid standards without excessive premium cost. Large ground power plants and government projects, Huawei, Sungrow, CATL, TBEA. Industrial-grade long-term stability and full compliance. Adapting to large asset operation and formal bidding requirements. Third, your budget range and profit orientation. Adequate budget, zero risk tolerance, long-term asset holding, top-tier flagship models. Fully hedged compliance and operation risks. Medium budget, balanced profit and risk, first-tier mainstream standard models. Stable performance, controllable cost, highest comprehensive cost performance. Tight budget, small short-cycle projects, reliable cost-effective standardized models. Meet basic operation needs, avoid overinvestment. Fourth, your O&M capability. No professional after-sales team, choose brands with remote diagnosis and full unit replacement. Reduce on-site operation difficulty and maintenance cost. Complete on-site engineering team, you can deploy high-power integrated systems for higher long-term power generation profit and asset return. Fourth, on-site mechanical and environmental physical constraint screening. Most project failures stem from mismatched on-site physical conditions, rather than improper equipment parameter selection. All equipment solutions must be pre-verified against on-site load and infrastructure constraints before finalizing procurement. For color steel tile rooftop distributed projects, confirm whether the building load can bear the 150 kilograms per square meter overall weight of liquid-cooled energy storage cabinets. For large-scale desert-based projects, verify whether the site allows 2000 volts high-voltage equipment. Tower spacing layout standards. For old factory renovation projects, check whether the existing transformer capacity supports the optimal 1.25 DC or AC ratio configuration. Even with perfectly matched equipment, projects will fail completely if the foundation and infrastructure cannot support operation. 6. 2026 Supply Chain, Pricing and Procurement Strategy plus Core Risk Warning. Supply Chain and Delivery Risk Control 2026 Key Upgrade. 2026 global trade barriers are escalating, and supply chain risks have become the primary factor affecting project delivery and profitability. First, COO certificate and tariff barrier avoidance. Under the US 301 tariff and fee policy, pure Chinese-made equipment faces high tariff costs and subsidy restrictions. For US market projects, prioritize Vietnamese and Thai-produced models of mainstream brands to meet local supply chain requirements and retain 30% ITC tax subsidies. Second, delivery cycle control. 2026 Q3 will usher in the traditional peak season of global PV and energy storage orders, with overall brand delivery cycles extended to 8-12 weeks. Large batch orders must lock production capacity 6 months in advance to avoid project delay penalties and stock shortage risks. Third, key spare parts guarantee. Do not only focus on whole machine delivery. Confirm the supplier's inventory of core consumables such as IGBT modules, cooling fans, and communication modules. Prioritize brands with global spare parts warehouses to avoid long-term shutdowns caused by missing accessories. A top misunderstanding for B2B buyers is equipping universal certification with formal grid connection qualification. Global regional grid access standards have been fully updated in 2026. And traditional certification logic has obvious loopholes. CE certification does not represent EU grid connection qualification. EU projects must additionally meet EN 50549 and VDRN 4105 latest grid code requirements. UL certification alone cannot support US grid connection, requiring compliance with IEE 1547 and California Rule 21 dynamic scheduling standards. Australia has fully implemented the updated AS or NZS 4777.2 to 2024 standard, eliminating old version certification access qualifications. Using 202 for version certificates to bid for and operate 2026 projects is equivalent to boarding with expired passports, leading to direct grid connection rejection. 2026 Pricing and Procurement Strategy. As a professional B2B buyer, I share the real insider pricing logic for 2026. New model launches pushed old model prices down 10% to 15%. You can purchase old versions for low standard informal projects to increase profit, but never use old models for formal compliance projects. Outdated parameters will directly fail grid inspection and subsidy audits. Batch order price thresholds you must know: 50 units and above, get exclusive agent discount. 100 units and above, access direct factory channels, save 3% to 8% intermediate cost. Large batch pre-order is the core of long-term cost control. Post-exhibition pre-order advantage is huge. Lock your intent order within 15 days after SNEC. You get the annual lowest price and priority production qualification, effectively avoiding Q3 peak season price hikes and stock shortages. Most critical engineer risk warning. Never buy simplified low-end versions from top-tier brands. They cut core temperature resistance and grid adaptation parameters to reduce cost. They look exactly the same as premium models, but fail frequently in overseas field operation. Small upfront savings lead to massive long-term project losses, including power generation losses, penalty fees, and equipment replacement costs. 7. 2026 Grid Connection Lifeline, Certification Iteration, Static Parameters and Dynamic Scheduling Pass or Fail Standard. Critical 2026 Certification Update and Common Traps. Moving on to one of the most make or break parts for 2026 overseas projects. Updated Grid Compliance Certification, Rigid Static Parameter Thresholds. and newly enforced dynamic scheduling rules. These are the definitive pass or fail standards that determine whether your project clears grid inspection and obtains official grid-tied qualifications. These rigid thresholds determine bidding pass rate, grid inspection results, and long-term asset compliance, non-negotiable for European and American formal projects. THD Total Harmonic Distortion 1.5 meets VD 4105 and Vol.07 for 1 Western grid standards. Generic cheap brands reach 3.5 and get rejected directly, causing project shutdown and rectification losses. 200 volts to 1000 volts wide voltage ride-through range, 0 voltage ride-through mandatory. For us or you grid-tied projects, basic qualification for grid access. 99.9% MPPT tracking efficiency, deciding long-term power generation revenue gap in high-price Western power markets. Full power normal operation from 30 to 60, no derating under extreme high or low temperature conditions. IP66 IP67 protection plus C5M highest grade salt spray resistance. Adapting to 25-year outdoor harsh environment operation. Hidden grid risk, 2026 dynamic grid soft rejection mechanism. Most buyers only check static grid compliance parameters, ignoring the newly upgraded dynamic grid support audit rule that has caused massive project delayed grid connection in Europe in 2026. Many projects do not fail formal inspections but suffer repeated rectifications, prolonged commissioning cycles, and hidden operational shutdown losses, which is defined as grid soft rejection. Germany, Poland, and core EU countries have fully launched dynamic grid support testing for new energy grid-connected equipment. Qualified inverters must support adaptive QV reactive voltage curve adjustment and real-time F or P frequency response linkage, actively matching grid dynamic fluctuation demands. In 2026, passing static parameter testing is never equal to passing dynamic grid scheduling inspection. Equipment without dynamic grid adaptation capability can operate normally during daytime peak power generation, but will be actively kicked off the grid by dispatching systems at night and during low load periods, resulting in invisible power generation losses that cannot be detected by conventional equipment monitoring data. 8. Warranty and after-sales risk control long-term buyer security. For overseas B2B buyers, after-sales service is more important than initial price. Long-term O&M capability determines the final profit margin of the project. Huawei, Sungrow, Qilin, Jinko have local warehouses and resident engineers in us or you or O, supporting 24-hour response and fast on-site repair. No long sea freight waiting for replacement parts, avoiding continuous power generation losses caused by maintenance delays. Avoid brands with zero local support for large formal projects. Cross-border after-sales cycle is long, and shutdown losses far exceed equipment price differences. Warranty matching rules, short trading cycle projects 3 to 5 years, 5 to 10-year basic warranty is enough to control cost. Long-term asset holding projects 10+ years must apply for 15 to 20-year extended warranty, and formal guarantee contracts to lock long-term operation safety. Storage projects prioritize brands with clear cycle life and decay compensation clauses, clarifying capacity attenuation standards and compensation mechanisms in the contract to avoid hidden asset losses. Core safety risk, energy storage, thermal runaway, cascading propagation, and insurance access rules. Capacity attenuation is the superficial risk of energy storage projects, while thermal runaway, cascading propagation, liability attribution, and insurance eligibility are the core safety and financial pain points for investors, insurance institutions, and long-term asset holders, the most overlooked blind spot of traditional procurement logic. 2026 Western project bidding, grid filing, and insurance underwriting have mandatory fire safety certification thresholds. Qualified energy storage systems must support multi-level fire protection coverage, including cell level, module level, and cabin level fire suppression, and fully comply with UL 9540A and 62619 and IEC 63056 International Thermal Safety Standards. The core procurement focus is not only equipment fire protection performance, but also clear contractual provisions, liability division for third-party property losses caused by thermal runaway accidents, and formal underwriting confirmation from insurance institutions. Energy storage systems that fail UL 95403 level thermal propagation testing are uninsurable assets in Europe and the United States. Such equipment cannot complete asset filing and long-term financing, and will become invalid fixed assets once accidents occur. Long-term O&M cost-saving tip: choose modular design products. 80% of minor faults only need single module replacement, cutting long-term maintenance cost by 60%. Prefer brands with free lifelong OTA upgrades to adapt new grid rules without hardware replacement, realizing long-term zero-cost iteration. 9. Practical Decision Toolkit 2026 Exclusive Plus Real Case Risk Review. Brand Selection Comparison Matrix. Below is a fully sorted, engineer-verified brand matching guide with applicable scenarios, Taboos scenarios, 2026 real delivery lead time and premium index, covering all mainstream top-tier brands for global PV storage projects. GCL best for desert large-scale photovoltaic bases, offshore or coastal anti-corrosion projects, airport and highway supporting PV facilities, and temporary mobile energy supply projects. Not suitable for conventional standard flat ground ordinary distributed projects. 2026 estimated lead time 7-8 weeks. Be a best for large government bidding projects, industrial park centralized PV storage integration, ultra-large ground power plants and high-value financing asset projects. Not suitable for small and medium-sized civilian distributed projects. 2026 estimated lead time 9-11 weeks. Huawei best for large EPC projects, US or U high-standard grid-tied and financing-compliant asset projects. Not suitable for ultra-low-budget small residential projects. 2026 estimated lead time 8-10 weeks. SINENG best for utility-scale large PV bases, industrial and commercial energy storage arbitrage. Weak grid high permeability grid-connected projects and grid frequency modulation or voltage regulation supporting projects. Not suitable for ultra-small low-budget residential orders. 2026 estimated lead time 7-8 weeks. SPIC best for national new energy-based projects, grid-level long-duration energy storage peak regulation, overseas high-temperature and high-humidity large-scale energy storage demonstration projects. Not suitable for small and medium-sized conventional distributed projects. 2026 estimated lead time 10-12 weeks. SunGrow best for utility-scale power stations, large batch EPC orders, and long-cycle energy storage asset projects. Not suitable for scattered small residential projects. 2026 estimated lead time 7-9 weeks. CATL best for extreme high or low temperature scenarios, Middle East desert projects, European high-latitude cold region projects and long-duration grid energy storage supporting projects. Not suitable for short-cycle, ultra-low-budget ordinary storage projects. 2026 estimated lead time 6-8 weeks. Jinlong best for European medium-sized commercial distributed grid-tied projects with balanced cost and compliance requirements. Not suitable for extreme off-grid weak grid scenarios. 2026 estimated lead time 6-7 weeks. GoodWe best for Southeast Asia, Africa, Latin America weak grid and off-grid projects. Not suitable for US or U high-standard grid compliance bidding projects. 2026 estimated lead time 5-6 weeks. DEYE best for global small residential bulk orders and small and medium-sized C&I distributed energy storage projects with loose compliance requirements. Not suitable for formal large-scale grid bidding and high-standard compliance projects. 2026 estimated lead time 4-5 weeks. SOLAX best for European, Australian, and Southeast Asian high-end residential and medium commercial PV storage integrated projects requiring low noise and high stability. Not suitable for ultra-large ground power station centralized projects. 2026 estimated lead time 5-7 weeks. Project pre-order self-checklist must check before ordering. Have I clarified the local grids that voltage ride-through and harmonic mandatory standards? Does the selected equipment support local mainstream communication protocols SunSpec or EE May 2030? Is the equipment's origin certificate compliant with local tariff and subsidy policies? Does my O&M team have modular replacement operation capability? Is the storage contract locked with clear cycle life and decay compensation clauses? Have I confirmed brand local, after-sales warehouse, and engineer response efficiency? Have I avoided top-tier brand low-end simplified versions? Real failure case warning. Last quarter, a European commercial project adopted low-cost generic inverters with that up to 3.8%, failing EU grid inspection directly. The project was forced to suspend operation for rectification, with a 1-month shutdown loss exceeding €200,000, plus equipment replacement costs. This fully proves that compliance parameters are not marketing gimmicks, but the bottom line of project profitability. 10. Exit strategy and long-term asset residual value protection. Most buyers only focus on equipment procurement, installation, and operation, ignoring the final link of the 25-year project lifecycle, asset exit, and residual value realization. For investment-oriented and long-term holding projects, the final asset transaction value often determines the project's net profit margin. Core procurement judgment standards for asset residual value. First, confirm whether the selected brand and equipment model are included in the Global New Energy Equipment Secondary Market Whitelist. Whitelisted equipment has standardized recycling and trading channels, with stable residual value and high liquidity. Second, verify the brand's official secondary operation system, including 10-year official refurbishment, cascade utilization, and equipment recycling channels, to avoid obsolete equipment becoming worthless waste after the warranty period expires. Third, prioritize brands that provide official residual value guarantee (ROVG) contracts. Clear official commitments on equipment depreciation rate and residual value effectively hedge long-term asset devaluation risks. In a 25-year project lifecycle, the final asset exit transaction often decides your overall final profit. 11. 5 fatal minefields for 2026 PV and energy storage projects must avoid. The following 5 mistakes are the most common and lethal pitfalls for global 2026 new energy projects, leading to grid connection failure, profit loss, asset depreciation, and even project scrapping. All B2B buyers and EPC teams must screen strictly. Adopting 2024 old version inverters and energy storage equipment for 2026 U or US high standard compliant projects. Expired certification, failed dynamic grid audit. Only focusing on initial CapEx procurement cost while ignoring long-term LCOE, insurance underwriting qualification, and hidden operation risks. Deploying energy storage systems without UL 9540 3-level thermal propagation certification. Uninsurable assets with zero risk resistance. Mixing inverters and batteries with incompatible private protocols, resulting in system communication conflicts and frequent offline failures. Only verifying static grid compliance parameters while ignoring local dynamic grid support scheduling rules, triggering long-term soft grid rejection and invisible power loss. 12. Episode 2 closing and next episode preview. Okay guys, that's all for episode 2. Today we built a complete 2026 inverter and storage selection system, covering market policy background, equipment performance, system compatibility, financial cost, supply chain delivery, compliance parameters, after-sales risk control, dynamic grid rules, asset safety, profit stacking, and long-term asset exit mechanisms. You can accurately match the right solution based on your local market rules, climate environment, project scale, budget range, and O&M ability. Always remember the core principle: engineering safety first, project profit second. Never sacrifice long-term asset value for short-term low-cost gains. In the final episode 3, we focus 100% on PV modules. Module selection determines your 25-year long-term ROI and asset residual value. I'll share tiered buying strategies for large, medium, and small companies, and help you avoid hidden long-term losses caused by module mismatch and quality attenuation. Subscribe and stay tuned for the most critical final episode. See you next time!